Yes, it's the protoplast.
So animal cell will have, they don't have that. So
But still an animal cell shrinks. No?
they shrink, but plasma cells.
हाँ concept इसे अपन apply करू शकतो.
मतलब cell में cell wall से दूर
हाँ it won't appear like this. Yes, but the cell will shrink. Okay. Remember, a plant cell can absorb water, but there is a limit to it. Why? There is a reason. We'll come to that. Okay. But an animal cell, if that absorbs water, there are filters. Okay. So this is endoosmosis हो गया, plasmolysis and deplasmolysis. ये 7 terms हो गया. Yes, all fixed. समझ में आ गया? Okay. Now when such a phenomenon occurs, okay, there is one more pressure that builds up inside the cell. What is it called? What is turbo pressure? Yes. It's a pressure that the cell they exert on the wall. Okay, yes. Okay. Now remember, when we try to define turbo pressure is always said to be a pressure which is generated. It's a hydrostatic pressure. Okay, it is generated because of water, and it is generated because of endoosmosis. Clear? Okay. When water starts moving in, turbo pressure builds up. Remember this. Okay. The thing is, when the turbo pressure builds up, turbo pressure is nothing but the pressure exerted by the membrane onto the wall. Okay. There is an opposite pressure also exerted by wall onto the membrane. Why? Because the wall is rigid. Okay, it is not flexible. Okay, so whatever pressure, as we are having this concept, yes, the cell membrane will exert a pressure onto the wall will have an opposite pressure on it. Okay, and generally for a plasmolized cell, okay, the wall pressure is going to be there. So wall pressure 0 या positive ऐसा हम लोग consider नहीं करते. Wall is always there. Clear? Logically. Okay. It's the turbo pressure that is building up because of the movement of water, because of endoosmosis. Okay. And the cell, if it is thirsty, it will keep on, drinking water or rather absorbing water, and it will swell at a point where it will become turgid. Turgid. Now in a turgid cell, we always say that wall pressure, osmotic pressure, as well as turbo pressure is equal. Okay, and such a cell doesn't have a thirst. As in it will not absorb more water. Remember. Clear with this? Okay. Then there is a term, okay, where you all have learned DPD, diffusion pressure deficit. Do you know the formula for DPD? OP minus TP. Okay, fine. DPD is equal to OP minus TP. OP म्हणजे काय? TP? Okay. So they have some values. We just defined osmotic pressure. So for a plasmolized cell, understand this. Why am I giving you this formula? It's because this is the exact formula for water potential. Okay? It's the exact formula for water potential, but with some different terms and different signs. This in understanding is easy. मग आपण water potential. कळलं? Okay. Now listen. There is a plasmolized cell you can see there. Okay. If I give a plasmolized cell on your hand, okay. Now you tell me the values for osmotic pressure and turgor pressure when a plasmolized cell is kept on your hand. पहिला osmotic pressure सांगा. Low or high? It's a plasmolized cell. High. Why? Because there is no water in it. There is more solute in it. But the osmotic pressure काय असणार? कळलं? Yes? Is endoosmosis taking place? No. It's only a lag. The turbo pressure आता मी consider नाही करत. Clear? Now what will happen? I put that cell in a hypotonic solution. What will happen? Endoosmosis will start. As the endoosmosis starts, turgor pressure starts building up and osmotic pressure starts going down. बरोबर ना? Water enter करते. Yes? Okay? The solute which was high, त्याचा concentration कमी होता. Clear? Okay? And at one point they both will be equal. That's where this will become 0. And that cell is a turgid cell. This tells us that water can't enter into a turgid cell. Something similar, त्यांनी आपल्याला अजून एक formula दिला water potential. Look, we are just talking about movement of water. Okay? We are just talking about how water enters into the cell, on what basis it enters. Okay? It all depends upon the concentration of the cell. The concentration is high, the water is going to enter. Simple. And in plants, such a osmotic pressure or such a concentration is always maintained in the cell because they want to transport water cell to cell. Okay? Clear? Look, this is something that we can't think about when we talk about the xylem. Okay? Xylem is totally different. It is very special. It happens short distance, cell to cell movement बद्दल बोलतो. Clear? Okay? Yes. So now we come to the concept of water potential. Now what is water potential? So in NCERT clearly they have mentioned that yes, water molecules, they have a kinetic energy. Okay, so it's the potential energy of the water. Okay, and this kinetic energy allows these water molecules to move from its higher concentration to its lower concentration. That's clear. Okay, so let's take an example here again. Okay. Just don't think about osmosis and anything. What I've done is in beaker A, I've taken PW. Pure water. Pure water. Okay, it's pure water. Now, in our book itself, it is mentioned pure water. When we talk about pure water, what is the water potential of pure water? Zero. Highest. Is the highest. Why highest? Because pure water molecules have kinetic energy. Every molecule has got that energy. So this energy is maximum. So this pure water or these molecules will have maximum ability to diffuse or to go for osmosis. Are you getting it? Yes. आपण zero बोललो ना तर एक जरा negative term होते. आपण विचार करता हा zero. No, it's not zero. It's maximum. Clear? Okay. Clear with this? Why maximum is because yes, every water molecule here, pure water, so it's a water molecule. Okay, and every water molecule here has the ability to diffuse. Okay, fine. Now, in this pure water, suppose I give you one glass of pure water, distillation करून दिले तुम्हाला. Pure water तेच असतं माहिती आहे. And I add 5 grams salt into it. किती grams salt add केला? What will happen? First, will it be a pure water again? No. What will it be? A salt solution. A 5% salt solution. Clear? So simple. Now you tell me, if pure water has maximum kinetic energy, okay, with which it will diffuse. Now is it a pure water? No. It's a solution. So its energy will be more or less? Less. Water potential will be negative. पहला concept कसा जाता है? कळलं? Okay. Now in this case, the more the solute I add, the value will go down. And ही value आपण काय बोलतो? Solute potential. We call this as solute potential. आता मी परत तुम्हाला दोन गोष्टी compare करतो. What is osmotic pressure? And it is a colligative property. It is directly proportional to the number of solute molecules present in the solution. आता मी solute potential बद्दल पण तेच बोललो, जितकं जास्त मी solute ऍड करणार व्हॅल्यू कमी होणार. हे बघा, इट इज द सेम. ऑस्मोटिक प्रेशर काय सोल्यूट पोटेन्शियल काय, दोघेही आपल्याला एकच समजवत आहे. काय समजवत आहे? More the solute, more will be the value. Of course, for osmotic pressure it is going to be positive. For solute potential it is going to be negative. कळतंय सगळ्यांना? Yes. Okay. Now, what happens? There is one more term to it. काय ते? Psi P. Okay. So water potential is equal to psi S plus psi P. ओके. आता बघा, इथे पॉझिटिव्ह आहे म्हणून इथे आपण ना सबट्रॅक्ट करतो. ही व्हॅल्यू निगेटिव्ह आहे म्हणून इथे आपण त्याला ऍड करतो. आणि दिस इज नथिंग बट टर्गर प्रेशर, प्रेशर पोटेन्शियल. कळतंय तुम्हाला? क्लिअर? प्रेशर पोटेन्शियल इज टर्गर प्रेशर. इट इज जनरेटेड बिकॉज ऑफ वॉटर एंट्री ऑफ वॉटर और एंडोऑस्मोसिस. ओके. and it will increase as water enters into the. क्लिअर? ते दोन्ही फॉर्म्युला सेम आहेत, फक्त याचे ना व्हॅल्यूज मध्ये जशी ती साइन असते ना निगेटिव्ह आणि पॉझिटिव्ह वाली, त्याचा डिफरन्स. दिस विल बी पॉझिटिव्ह, दिस विल बी निगेटिव्ह. आणि सोल्यूट पोटेन्शियल निगेटिव्ह. हे बघा, प्रेशर पोटेन्शियल पॉझिटिव्ह असतं. प्रेशर पोटेन्शियल इज पॉझिटिव्ह. ओके, म्हणजे टर्गर प्रेशर. कळतंय? ओके. Solute potential is negative because when I add solute into water, it is a solution. Okay, and this will decrease the kinetic energy of water molecules, and they will have lesser ability to diffuse. कळलं? आता मला सांगा, मी तुम्हाला दोन सेल्स दिले. One of the cell has a water potential value of -7 and the other has a value of -9. Okay, this is cell A, this is cell B. From where to where the water will move? Why? Yes. Clear? A is a water potential higher. Okay? Higher, म्हणजे definitely we know one thing, water will always move from higher water potential to lower. Clear with this? Okay? Or for ease, we can always say water will always move from less negative to more negative. हे बघा, निगेटिव्ह स्केल मध्ये -7 is higher and -9 is lower. So from higher to lower. कळलं water potential म्हणून? Any questions? Sure. Go through water potential. Water potential आहे, बरंच आहे का वाचायचं? Clear out this concept. It is not that difficult, but just understand. एसी के टेम्परेचर का क्या किया तुम लोगों ने? गरम हवा आ रहा है। रिमोट आया ना? भाई झालं रीड करून हो. Okay, just read osmosis and come down to those questions as well. किती गेलं? किती होतं? किती होतं? 24 आणि गरम हवा येते ये भी हाँ दे इथे अजून एटमॉस्फेरिक प्रेशर वाटलं नॉर्मल म्हणजे एक्सटर्नल प्रेशर मी काही देत नाही. केमिस्ट्री नाही बाबा नॉर्मल गप्पय राहतात. केमिस्ट्री नाही आहे ते मला एक्सटर्नल प्रेशर किंवा मी वेगळं प्रेशर घेते काही नाही नॉर्मल सगळं नेचर मध्ये होत आहे. मग काय असणार प्रेशर एक्सटर्नल प्रेशर बायोमध्ये सिंपल असतं. इथे आहे का दिलाय? नेक्स्ट स्लाइड वर जास्त प्रेशर नाही आजकाल water will move from containing water at higher water potential to the one having low water potential. Down again of the energetically positive. Anything that is good has got more. Which is always going to be higher or lower and depending on that Done? अच्छा, osmosis से खाली के questions है. You know answers to those questions? Yes? Okay, fine. I'll ask the first one. Solution of which chamber has lower water potential? Okay. Solution of which chamber has lower solute potential? Yes. It will be B. Well, जिसके जास्त solute तिसको solute potential कम. What are they asked? Check. Yes, कळलं की नाही कळलं? एक सेकंड आहे बघा, मी एका वॉटर मध्ये एका सोल्युशन मध्ये एका बीकर मध्ये 5 ग्रॅम सॉल्ट ऍड केलं आणि दुसऱ्यामध्ये 10 ग्रॅम सॉल्ट ऍड केलं. आता कोणाचं सोल्यूट पोटेन्शियल कमी आहे? 10 ग्रॅम मध्ये. करेक्ट. So now check where the solute is more, that will have a lower solute potential. Clear? B. Okay? सगळ्यांनी एकत्र हे आन्सर करा, कारण की काही काही असे एक करतात, काही काही बी करतात, म्हणून ते मी डिस्कस करतो. नेक्स्ट क्वेश्चन काय? जिथे वॉटर जास्त तिकडनं जिथे कमी. नेक्स्ट काय आहे? This solution has a higher solute potential. At equilibrium, which chamber will have lower? No, it will be equal. मग तो F वाल्याचं काय बाबा? Which of this has higher water potential? -1000. आणि मग नंतरचं how will it move? 0.2 to 0.1. Higher to lower. एवढं लक्षात ठेवा. Clear? नेक्स्ट पुढे काय वॉटर पोटेन्शियल ऑस्मोसिस. आता एक ऑस्मोसिस मध्ये त्यांनी एक छान एक्सपेरिमेंट दिला. केलाय का तुम्ही कॉलेजमध्ये एक्सपेरिमेंट? पोटॅटो जरा पण नाही गेले यार. Potato osmosis. Yes. Okay. Now, why listen? Look at that experiment. Today, you can see the funnel there. Okay, thistle funnel experiment. Yeah, then osmotic pressure can explain here. Okay. Now, what do you see here? You can see a thistle funnel. To one end of the thistle funnel, they have attached a membrane. Yes. Yes. Can you see that membrane? आणि त्या funnel मध्ये काय ठेवलंय त्यांनी? Sucrose solution. Okay. And this funnel is now dipped into pure water. What will happen? Yes, water will start entering into the funnel, and the level of the water or the solution of sucrose in the funnel will increase. Color, okay? This proves that water moves from its higher water potential or its higher concentration or its higher chemical potential to its lower. Clear? Okay? आता ह्या तुम्ही ऑस्मोटिक प्रेशर डेमॉन्स्ट्रेट कसं करणार तर त्याचा बाजूचा डायग्राम बघा. एक्सटर्नल प्रेशर इज अप्लाइड. कॅन यू सी दॅट? ओके. टू स्टॉप ऑस्मोसिस या सेकंड डायग्राम मध्ये एरोज नाही म्हणजे ऑस्मोसिस थांबलं and that external pressure is what we call it as osmotic pressure. Okay, I require more pressure if the solution, the sucrose solution is more concentrated. Remember that. Clear with this? Yes. So that is all with respect to the osmosis. Please go through it. Then also go through plasmolysis. इसलिए पण सगळे terms आपण केलेले आहेत. Solute potential आणि osmotic pressure. ते कुठे बोलतो? Okay, one question. When exoosmosis takes place, okay, from where does the water comes out first?
Cytoplasm.
ही लाईन आहे NCRT. आपण डायरेक्ट व्हॅक्यूल वर जातो पण NCRT मध्ये मेन्शन केलेलं आहे. सायटोप्लाझम पर्यंत पहिलं झालं मग व्हॅक्यूल. Yeah, solution for this solution will take hypertonic. The solution in which it is present, that solution will take that. And we cell wall are completely permanent. Done reading? Okay, see this diagram. You will see three types of cells, which are those. Okay, so plasmolysis occurs when water moves out. Turgidity occurs when water enters it. When there is a equilibrium, not equilibrium, but then there is kind of a balance with respect to water take up and water kind of getting out. That cell is called as a flaccid cell. Clear? Okay. Now, a question that is asked. What that question asks is, plasmolized cell है, the space between the cell membrane and the cell wall. Oh, which solution takes that space? The solution in which it is present. Exoosmosis takes place when I place a cell in a hypertonic solution. Water will start moving out, cell will start shrinking. Remember one thing, a cell wall, is freely permeable. It allows everything to pass. It is a membrane that is selectively permeable. Okay, so this space is always going to be filled up with the solution which is present outside, and that is the hypertonic. Hypertonic मध्ये ते होतं ना काय बोलतो आपण exoosmosis के plasma. So that space is taken up by the hypertonic solution. Clear with this? Yes. Any questions here in this part, or else we'll go to the imbibition. Yes, pressure potential. No idea. Wait. Anything else left in osmosis? No, ते झालं. Plasmon solution झालं. अजून काय आहे? आता last imbibition. Okay. Yes. Tell me what is imbibition? Okay, a special type of osmosis. Okay, fine. But have you ever experienced imbibition? Where? Yeah, the dose, kind of anything that is wood in it swells. Okay. Why it swells is because wood is made up of hydrophilic compounds, cellulose, lignin. They have the ability to first adsorb and then absorb water. It's like they are hydrophilic. Okay, so remember any solid that is hydrophilic, it is going to imbibe water. Clear with this? Okay. And imbibition has a lot of applications in nature as well. When if I talk about what do we say, seed germination takes place because of imbibition. Yes, the swelling of the doors that happens in rainy season is also because of imbibition. Then if I just talk about a wooden log, okay, as water falls on it, it actually changes the shape, or rather it swells, okay. It is also because of imbibition. They have mentioned one application in NCERT. I don't know how many of you have known it or not, okay, but our ancient technique to break huge rocks, okay, what was it? एक wooden piece है ना, त्या crack मध्ये place करायचं, और त्याच्यावर water टाकायचं. The wood swells, okay, and it breaks that entire boulder. Okay, so that was one of the way. So आणि फक्त एवढं ऑब्झर्व केलं की wood swell करतात. आता आपण त्याला सायंटिफिकली बोलतो बरोबर imbibition होतं, wood swell करतात. Clear? And that is how we used to use imbibition. But remember one thing, the last point of imbibition is here really very important. It is the affinity between the adsorbent and the liquid. The surface that is absorbing it, or any compound that is absorbing it, okay, it is going to have a higher affinity towards water, and that is how imbibition is going to take place. That's why I always say when we talk about these hydrophilic compounds like cellulose and pectin, lignin, okay, they are going to absorb water. And remember one thing, when we talk about imbibition, एवढं पण डोक्यात ठेवा की imbibition is the first phenomenon which allows plants to absorb water. Can anyone explain me why? Imbibition is the first phenomenon which allows plants to absorb water. Why? Seed coat काय आहे? मी काय बोलतो? Allows plant to absorb water. Seed वर वगैरे कुठे जाते? मी plant बद्दल बोलतो. Simple. Water जेव्हा प्लांटच्या कॉन्टॅक्ट मध्ये येतं तेव्हा which part of the cell is going to come in contact first? Cell wall. What is cell wall made up of? Imbibition. First layer is cell wall. Cell wall comes in contact with water. It is going to imbibe water. Plants are naturally kind of त्याच्यात ती ability दिलेली that it will only keep on absorbing water. Clear? Okay, so that is imbibition. Go through imbibition. हे photosynthesis MCQs केले ना सगळे? Target you also done? Done? जर्मनी बाहर ही आहे रे जरा पेन आ रही है Japan is playing well. They are very quick. हाँ
पेज नंबर
कुठल्या वाल्या याद आहेत का ते What a potential gradient between